histogram of oriented gradient. So how this hog histogram of oriented gradient will work? Initially, if you take image, this is the original image, 720 into 475, that is the size, into 3, that is the RGB. Now what I'm going to do is I'm going to detect this particular person throughout the end. Okay. So if I want to detect this person, I'm going to crop. So when I crop, the size is 100 to 200. And then I'm resizing that to 64 cross 128. So you may ask why this particular size. So the creator of this algorithm specifies this size, and it is quite working, and it produces better results. So that's why I'm stick to this 64 cross 128. So this is the basic thing in the algorithm. So first step in this algorithm is resizing your picture. So that's the basic thing. After that, what we are going to do is we are going to apply the derivative. So what is this derivative does? It measures the rate of change. There are three things. One is zero derivative, small derivative, and high derivative. What is the zero derivative output shows when the derivative output is zero? What does it means is there is no variation in the color. For example, if you take this image, that yellow t-shirt, the difference between this place and this place is almost zero because it is the same t-shirt and it's of same color. So there will not be any variation. So derivative actually gives us the variations. So that comes under zero derivative. What is this small derivative value is? When the variation is very much less. For example, if you take the floor here, it is ash color and there is some Olympic symbol is there. So it is little bit variation. There is not a much variation. It's a small variation between this place and this point. So that comes under small derivative output, and then high derivative value. If the value is high in the derivative, that means the variation is very much there. So that means, for example, if you take the shoulder, it is brown in color, and if you take the background, it is action color. Are you able to understand? So the values of this derivative, when you apply the derivative, histogram is basically work based on the derivative functions. When you apply the derivative, you will have different types of values, either zero or small or high. So what that means is it is representing the variations of the colors. Another important thing that you have to understand here is gradient vector. What this vector will do is it gives the direction of the values. It gives the direction. You can see here. So this is the top of the head. So when you zoom it, you will have some blue arrow here. Can you able to see it? Okay, you can see some blue arrows. Okay, these are blue arrows. These arrows represent the direction of the changes. So if you see above the head, there is some pixels, 1 pixel, 2 pixel, 3 pixel, 4. So the variation between this pixel is less. But when you come to the top of the head, the variation between this point and this point is high. So that's why the direction is upward, and it has some angles. That angles represents in what angle the variation is high. So it gives the direction. Gradient vector gives the direction and the derivative gives the magnitude. So after applying the derivative and gradient vector, you will have a array like this. You can see this array. Okay, so I quickly repeat it. Histogram of oriented gradient starts with resizing the image to this particular dimension, because that is the optimum one that will produce good results that was created by the creator. Okay. After that, the mathematical, how the things will work is, it is worked on the two things. One is derivative, another one is gradient vector. The derivative gives us the magnitude of change, and the gradient vector gives the direction of change. In what direction the changes will be high. So that is the part. So based on this gradient direction and gradient magnitude, histogram will be created. I will tell you what is histogram. So how this histogram will be created? For example, if you take this 80, 80 is the first pixel. Okay, as the top of the pixel. It is a direction. Here, the direction represents the angle. Okay, the first pixel. If you take the first pixel, the direction of this angle is 80 degree. Okay, and corresponding magnitude change in the color. If you take this part, this is the image that you are working on. The change here is very much less because almost it is hash. The change will be high only in this area. You can see here in this area, the magnitude will be high. Are you able to understand this? So it is the direction is 80 degree. The corresponding magnitude will be 2. Here you have the histogram of gradients graph. This is an angle 0, 20, 40, 60, 80 up to 160. Here some values are comes at 170. What that means is, if it comes beyond that 170, it will be accommodated in 160 to 180 thing. 180 is nothing but 0. You know, when the angle is 180, it is opposite to 0. Okay, so it will be shared to this point, to the 0 angle. So we will see 80 is the angle that is there. What is the value of that 80 is 2. Again, here also some 86 is there. The corresponding magnitude will be 196. So here 80, and it in between 80 and 100, this will be shared because there is no exact 80. And if you come to this 10, 10 is the angle and 4 is the magnitude. Where is the 10? 10 here is 0 to 20. So the value, the angle is 10. Since it is 10, it is divided by 2. The 4 will be divided by 2 and it is placed as 2, 2. So like that, these two arrays are mapped to form a histogram. Okay, histogram is basically gives the number of occurrence. Histogram gives the number of occurrence in that particular class. So this graph is formed based on this method. So all those things that code will take care. Okay, that function will take. After the application of the histogram, okay, your image will be look like this. So this is the direction, another point. Here you can see there is the shape of the body. You can see there is some gradient, direction, magnitude. Okay, all those things represents the shape of the body. Okay, so that is the output of the histogram feature. This is some of the samples. How it is look like? Can you see? Can you see this image? How it is look like? It looks like a face. There is some eyes. There is some eyes, nose. Okay, so this is the feature of the image. Feature of the face. If you apply this to the original image, then it identifies the face. So similarly, you can see it is a body shape. If you apply this feature into the original image, it will identify the body. Here you can see there is some circle over here. What is the circle? Circle represents the clock. If you apply this to the clock image, it will detects the clock in that image. So this is output of the this is the output after the application of hog. Okay, after if you apply a hog in the training image, you will have the you have this output. This is the template that you have to apply to all the original images to get the result. So that is the working of HOG, H-O-G, histogram of oriented gradient. So it's basically working based on the gradient as well as derivative. So with that quick uh, introduction about histogram of oriented gradient, we will move on to the coding part. If you want to learn more about this histogram, you can. Okay, so this is the theory of this. Learn OpenCV.com histogram of oriented gradients. So in this website, you can see what is gradient and what is angle. How we are calculating the magnitude and angle. So this is the back work of this. So you can work on this. You can learn to understand better. Now we move to the coding part. So in the last class, yesterday's class in the R cascade, we have used the CV2 library functions. Here we are going to use dlib. Dlib is another popular library function that is basically used for detection, object detection, face detection, any type of detection, computer vision work. So we have the website called dlib.net. It is a library function. Using that only, we are going to apply the org. So now we go to the coding part. The first statement is import dlib. People to image that I have to copy from my folder. So here is the people to image, copy and paste it. Run it. You will have images. You can see there's lots of faces. All are frontal faces images. So I can apply frontal face function, org. So I'm going to use org. So that is a variable name. Dlib is the library function. Dot get. You can see here, I'm not uploading the XML file here because org can directly, org has dlib as functions for lots of things. For example, you can say face chip details. Okay, histogram, rect, and frontal face detector. So you have a default function. So I'm just using that. Only for R, you need XML creation. And then I'm running this. Now, a face detector training model is created. After this, I'm going to apply this on my images. So for that, I am creating the variable called detections and face underscore detector. Okay, face detector underscore org. So that is the training model. After the image. So the name of my image is image, just image. So I'm just putting it and then I'm running. So when I run here, I will not get any output. So let's see whether I'm getting the output or not. So detections. Here you can see the rectangles is created, but there is no detections here. The reason is I have to include one of the parameter like a scale factor in the R cascade. Okay, so I have to do it 1. So if I do that and then I'm running again the output, you can see there is lots of detections. Here also the detection has 4 parameters. One is 429, 38, 465, 75, but it is not in the form of R cascade. It is slightly different. So let's see how many detections are there. For that, length detections. And then run it. You can see there is 14 detections. Let's see how many phases are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there is 14 phases. So all the phases will be are detected. It's working perfectly. So that's why this histogram of oriented gradient is better than R cascade. But not in all applications. For this particular applications, this is working better. Because in R cascade, these two phases are not detected. If you remember, this phase and this phase are not detected, even though we change many parameters. So next step is we have to create a rectangle shape. For that, we have to use the for loop, and we create one variable for the for loop in detections. We apply all this value into the for loop. So if you run this, you will have values like this. So this is the phase value. That's the total value 429, 38, 465, 74. This phase detection. What is the left value? Left value means from this point to this point. What is the left value for this 429 is 429. And top means from the top. Bottom means from the bottom. Right means from the right. So this is basically the parameters. So just to see the parameters, I'm showing it. Then you can relate the with the rectangle. I'm commenting that I don't want this to be run. The same thing what we have done in the R cascade, we are going to do the same thing. Okay, so but slightly different. We are doing that in the form of left top or B. So that is how the algorithm sees it. Left, next phase dot top, next phase dot phase dot right, next phase dot bottom. Okay, so what this code part does is the phase left value, that is nothing but 429. We are pasting that in the L. Top value 38 in the top, and right value 465 on the R, and bottom 74 on the B. So we are placing that. After that, we are going to use the CV2 library function for the rectangle to draw the rectangle on the face. We are not using CV2 for finding, for classifying, for detection. We are using CV2 for rectangle alone. For classification, for detection, we have used dlib. Remember that. I'm just doing the starting point and the ending point. Under the color, okay, I'm going to make it yellow color for the difference. And then the width, if you want more bold, you can make it as 3 or 2 like that. Finally, cv2 dot underscore im show image. Okay, so now we can run this. I don't need any values. I just want the detection. See here, only one is detected. But wait, it is loading. we will have all the detections because there is 14 here. Okay. Now you can see all the 14 phases are detected. So from this, you can say this HOG is working better than R cascade.